Welcome to the Humiseal booth here at SMT Hybrid in Nuremberg. Joined by Chris Palin. Nice to see you again, Chris.
And you?
I want to talk a little bit about conformal coatings and the rise in conformal coatings, which has largely been driven by high reliability applications, notably autonomous vehicles. Can you talk to us a little bit about that?
Yeah, indeed. Well, I mean, electronics is proliferating everywhere, but certainly automotive. I think the technology change is quite drastic right now, and driving that, as you quite rightly say, is autonomous vehicles. And one of the key factors in for the electronics in an autonomous vehicle is reliability, because previously you've had certain areas of the car where you've had to have, I guess, more reliability than others, things like airbag systems, safety systems. But now you've got the driving systems, the intelligence, the artificial intelligence systems, etc. There's a lot more electronics, and the reliability just has to be much more. So as far as we go on conformal coatings, really, obviously coating, but it's really more the process. So we're looking really back, I guess, towards almost military systems. Military systems, generally they're all cleaned. So I think there's going to be a return to cleaning of electronics. Ultimately, you have to know what's on the surface of the board. If there's nothing on the surface of the board, this is good.
Yeah, I mean, well, just to sort of put a bit of background into that, typically about only 20% of people currently clean before they coat, which is quite an astounding number. But you're actually starting to see a rise in this because of the high reliability.
Yeah, indeed. Yeah, I've also probably been in this industry far too long, and remember when people used to clean, kind of previous to no clean pastes, etc. But so we're seeing a return to cleaning. And cleaning with cleaning chemistries, traditional semi-aqueous, etc., some vapor systems, and also inline plasma systems we see more now. So
the inline plasma, though, I mean, they're using that as a secondary process. So they're doing an aqueous clean first and then using the plasma to basically give get the surface adhesion a bit better.
Exactly, yeah. It really... It doesn't last, you plasma clean, it doesn't last forever, but it lasts long enough to increase the surface energy of the board to make sure that the coating's going to stick, and it's going to stick for a long time. So,
Now, you touched on autonomous vehicles. The number of sensors is rising, the volume of electronics is rising exponentially, but they're getting smaller because they've all got to fit into the same car. So from a Humiseal point of view, then presumably you're going to be selling less area of coating in one respect, but then possibly more in volume because of the electronics.
Yeah, I mean our volume thankfully is increasing year on year, which is good. But yes, you're right. The boards are getting smaller and they're becoming increasingly more difficult to coat. The accuracy of which you can coat a circuit board with today's systems, we're seeing an increase in jetting, for example, for smaller areas, dispense, because the kind of using a film coater type application for a big board where you've had to go fast is not really true for a board which is only maybe a couple of centimeters square. So.
Talking about jetting and line definition and that type of thing, is it better to use like a tight jet where you're getting a tight line definition, or is it better to mask? Because some people believe in masking all the time, which is very labor intensive. But is if you're going to do a real high end job, is that the only way to do it?
It's a tricky question, actually. I mean, we sell quite a few masking materials. Tapes, dots, etc. We also sell UV cure masking materials. It's all about speed of process, and as you say, it's quite labour intensive. So the more the more efficiency you can get in masking, the better. But there's really two schools of thought. One is to do it with masking, and the other is to maybe use a dam and fill type application, which again will slow the process down slightly again, but you don't have the manual input. So it's really, I guess, could be a question of where in the world you do this as well.
Exactly. Well, it's interesting because I saw at Productronica a really cool dam and fill process from a company that was doing 3D printing. So you could literally dam and fill whatever area on the board you actually needed to do.
Yeah, I think there's going to be a lot of interest in the future in, I'd say, alternative coating or possibly alternative construction methods around the board, which I think is going to involve probably 3D printing, whether that's in liquid or solid form. But yeah, I think in the next probably 5 to 10 years, I think there'll be a big change because I think there's going to be a drive for the production line not only to do the SMT, the SMT, the cleaning, the coating, but I think also to construct the box on the same line. It's a very expensive part, certainly for automotive electronics.
Fascinating discussion, Chris. Thank you for joining us today. Okay.
See you again.